welcome to another exciting class with Mr. Simplicity. Today we'll be looking at another aspect of differential calculus. And we're looking at inverse trigonometric functions. How do we solve problem on inverse trigonometric functions? Let's then into the example. Okay, so
this example says y is equals to sine inverse of x. And in solving inverse trig function, provided there's no coefficients behind the inverse trig function, the first thing to do is to reverse the trig. Remember, sine theta equals to x leads us to theta equals to sine inverse of x. Okay, so that means I can come back here by taking the sign backward. So if I apply that to the question we have, that is what I mean by reversing the trig function. So if I reverse it here, I'm going to have sine y equal to x. So if I have sine y equals to x, I can differentiate both sides with respect to x. Differentiate both sides with respect to x. Differentiate sine y. From our table, sine gives us cos. So I have cos y. Since it's with respect to x, I will attach the y dx. If I differentiate x, I have 1. Make the y dx subject of the formula. That means cos y we have to divide. So I have 1 over cos y. It would have been so interesting if this is where we'll stop. But no, I need to remove y from this expression. And that will take us to our trigonometry identities. Among the basic trigonometry identities, there's one that relates cos and sine. Let's quickly recall it. It says sine theta. Let me use sine. Sine square y plus cos square y is 1. That's what it says. This identity says sine square y or sine square theta plus cos square theta is 1. So from here, I can make cos y subject of the formula. If I do that correctly, I'm going to have cos square y equals to 1 minus sine square y, and cos y will be equals to the square root of 1 minus sine square y. So if you go back to the main question, sine y is x. Is that not so? Let me note this as equation 1. So from equation 1, we know that sine y is x. That means sine square y will be equals to what? X squared. If I put it back here, it means that cos y will be equals to the square root of 1 minus x squared. So now come back to our solution. Let me call this equation 2. That's our solution, right? So I want to come back here and replace cos y. So therefore, the y over dx will be equals to 1 over square root of 1 minus x squared. Problem solved. We reverse the trig, differentiate both sides, make the y dx subject of the formula, then eliminate y from your answer. It is this eliminating y from your answer sometimes that is the big problem. Okay, so we're going to take another example on this. Okay, let's take a look at this second example. It says we should differentiate the sine inverse of square root of sine x, which means you are given this to find the y dx. Okay, so first thing, reverse the trig. So I have sine y equals to square root of sine x. Before I differentiate, remember from the law of indices, this is the same thing as sine x raised to power half, right? So now let's differentiate. So if I differentiate sine y, I'm going to have cos y dy over dx. Okay? Then differentiating this, I'm going to apply power rule because this is a complex function of x and a constant power. Remember power rule? And what it simply means is differentiate the base, which is du dx, times differentiate the whole, which is dy du. So if I differentiate the base, which is sine x, I'm going to get cos x times differentiating the whole means drop the power and subtract 1 from the original power. Half minus 1 will give us minus half. Okay? So if I simplify this, this is cos x times sine x raised to power minus half all over 2. Call this half. Or you can bring the half to the beginning. So to make this power positive, you can take it down further to be cos x all over 2 sine x raised to power half. So half is also the same thing as square root of sine x. Okay? So this will give me cos y dy dx will now be equals to cos x over 2 roots sine x. That's what it means. Next, I can make dy dx subject of the formula. If I do that, it's going to give me cos x over 2 roots sine x times cos x, cos y. For this guy, we have to divide. So now the problem here is to eliminate cos y. So I'm going to fall back to that basic identity again that says recall sine square y
plus cos square y.
Cos y subject of the formula, we have the square root of 1 minus sine square y. Okay? If you come back here, so it means whenever I see sine y, I can replace it with square root of x. So from 1 sine y is equals to root sine x. So sine square y will be equals to sine x. This implies that cos y is equals to square root of 1 minus sine x. So I can go and replace this in my answer. Do you get it? So because of my space, can I put it there? Yes, I can. So it means that dy over dx is equals to cos x over 2 root sine x root 1 minus sine x. So that's our answer. Okay, good day, viewers, and welcome to another exciting class with Mr. Simplicity. Today we'll be looking at the topic logarithm functions. We want to look at some problems that will involve the rules of logarithm as we differentiate them. Okay, I'm going to be looking at a few examples in this video, and I hope you are able to get the idea behind problem of on logarithm differentiation. So let's look at this question. Okay, problems on logarithm functions are usually centered around power rule to say where the power is not constant. Okay, they are indices, but the power is a variable. When we see problem like that, we can always apply this procedure of logarithm differentiation. So if you look at this question, they say we should find dy dx, given that y is equals to x raised to power 6x. What I need to do here is to first of all take the natural log of both sides. So I'm going to have ln y equals to ln x raised to power 6x. The essence of taking the natural logarithm of both sides is to be able to drop this power here. So this will become ln y equals to 6x ln x. Okay? And when you have done that, you can differentiate both sides. If you differentiate ln y, that's 1 over y dy over dx. We are differentiating with respect to x, remember? Then if I'm differentiating these guys, this is product true. So leave the second, differentiate the first, plus leave the first, differentiate the second. When we simplify this, we'll be having 6 ln x plus 6. Okay? Bringing us to 1 over y dy dx to be equal to 6 brackets ln x plus 1. But is dy dx is
looking for. So I need to eliminate this y here. So I multiply through by y. That will give me the y
over dx equals to y into 6 brackets ln x plus 1. This is the same thing as y times 6 is 6y into ln x plus 1. But as usual, that y is not needed in my answer. So what is y from the beginning? Y is x raised to power 6. Y equals to x raised to power 6x. So this implies that the y over dx is equal to 6 x raised to power 6x bracket ln x plus 1. So this is how we solve problem like this. Let's take another example. Okay, let's look at an example like this, where y is equals to sine x raised to power x. The process remains the same. It's a logarithm function because the power is a variable. So I'll take logarithm of both sides. If I do that, I'm going to have ln y equals to ln sine x raised to power x. Remember, the aim of taking the logarithm is to drop the power. So I have ln y equals to x ln sine x. So the next thing is to differentiate both sides. If I differentiate the y, I have 1 over y dy
over dx is equal to, you see this is product true, so you leave the second ln x ln sine x times differentiate the first, that's 1, plus leave the first, differentiate the second. So differentiate the second is chain rule, so you differentiate the chain first. You differentiate the chain ln sine, if you differentiate the chain sine s, it will give you cos s. Cos x.
if I
Differentiate the whole, it will give you 1 over sine x. So now we simplify. 1 over y equals dy dx equals to ln sine x plus x cos x over sine x. We can still simplify it further. So this will give us 1 over y dy dx equal to ln sine x plus x cot x, because cos over sine is cot. So making the y dx a subject of the formula, we have ln sine x, y ln sine x plus x cot x. Now remember y is equals to sine x raised by x. Y equals to sine x raised by x. So if we replace y, we're going to have finally dy over dx to be equals to sine x raised to power x into everything in the bracket ln sine x plus x cot x. So that's the answer. So thank you for staying to the end of this video. We really appreciate it. Please don't forget to like, subscribe and share. God bless you.